Imagine a machine so advanced that it can fly through heavily defended airspace without ever being seen, tracked, or even heard until it's far too late. That's the idea behind extreme stealth, one of the most powerful and secretive capabilities in modern military technology. It's not just about being invisible, it's about controlling every possible way an enemy can detect you, from radar waves to heat signatures, from sound to even the faintest electromagnetic emissions. To understand extreme stealth, you first have to think about how detection works. Traditional radar systems send out radio waves that bounce off objects and return to the receiver. The bigger and more reflective the object, the easier it is to detect. Early aircraft had no way to hide from this. They were big metal bodies flying in the sky, perfect targets. But stealth changes that equation completely. Instead of reflecting radar waves back to the source, stealth platforms are designed to scatter those waves in different directions. This is achieved through carefully angled surfaces, smooth contours, and specialized coatings. When radar waves hit a stealth aircraft, they don't bounce straight back, they deflect away, making the aircraft appear much smaller or even invisible on radar screens. But shape alone isn't enough. Extreme stealth relies heavily on advanced materials. These are often called radar-absorbing materials, and they work by soaking up radar energy instead of reflecting it. Imagine throwing a ball at a wall versus throwing it into thick mud. The wall sends it back instantly, but the mud absorbs the energy. That's exactly what these materials do to radar waves. Then there's infrared detection, which tracks heat. Every engine, every moving part, produces heat, and modern sensors can pick up even slight temperature differences. Extreme stealth systems deal with this by carefully managing heat output. Engines are buried deep inside the aircraft, exhaust is cooled before it leaves the aircraft, and sometimes even mixed with cold air to reduce its thermal signature. The goal is simple: make the aircraft blend into the background temperature of the sky. Sound is another factor. While you can't completely silence a jet engine, stealth designs reduce noise as much as possible. Smooth aerodynamic shapes reduce turbulence, and engine placement can help mask sound from reaching the ground. At high altitudes, this makes the aircraft extremely difficult to hear, especially compared to older, louder designs. But perhaps the most fascinating part of extreme stealth is electromagnetic control. Modern aircraft are full of electronics, radars, communication systems, sensors, but every signal they emit can potentially give away their position. Extreme stealth platforms use something called emission control, or EMCON. This means they limit or carefully manage when and how they transmit signals. Sometimes they rely on passive sensors instead, which detect enemy emissions without sending anything out themselves. This turns stealth into more than just a design feature, it becomes a strategy. A stealth aircraft isn't just hiding, it's hunting. It can gather information, track targets, and even coordinate with other systems without revealing its presence. Now, consider how all these elements come together in real-world operations. A stealth mission often begins long before the aircraft even takes off. Intelligence teams study enemy radar coverage, air defense systems, and patrol patterns. Flight paths are carefully planned to exploit gaps in detection. Every move is calculated to minimize exposure. Once airborne, the aircraft operates in a completely different way compared to conventional platforms. Pilots rely heavily on onboard sensors and data fusion systems, which combine information from multiple sources into a single, clear picture. This allows them to maintain situational awareness without using active radar, keeping them hidden. As the aircraft approaches its target, its stealth capabilities allow it to penetrate deep into defended territory. Enemy radar operators might see nothing at all, or at best, a faint, inconsistent signal that's easy to dismiss as noise. By the time the aircraft is close enough to strike, it's often too late for any meaningful response. And that's the true power of extreme stealth. It compresses the enemy's reaction time to almost zero. Traditional defenses rely on early detection, tracking, and interception. Stealth disrupts this entire chain. If you can't see the threat, you can't stop it. But extreme stealth isn't invincible. Advances in detection technology are constantly challenging it. Low-frequency radars, for example, can sometimes detect stealth aircraft at longer ranges, though with less precision. Infrared search and track systems are becoming more sensitive. There's also growing interest in using artificial intelligence to analyze patterns and identify anomalies that might indicate a stealth presence. This creates an ongoing technological race. Every improvement in stealth is met with new detection methods, and every new sensor leads to further refinements in stealth design. It's a cycle of innovation that never really ends. Another important aspect is cost and complexity. Extreme stealth platforms are incredibly expensive to develop and maintain. The materials, the engineering, the testing, it all requires massive investment. Even small changes in design can have huge impacts on performance, which means years of research and experimentation. Maintenance is also a challenge. Stealth coatings can be delicate and require constant care. Even minor damage can affect the aircraft's radar signature. Ground crews need specialized training and equipment to keep these systems in top condition. Despite these challenges, the strategic value of extreme stealth is undeniable. It allows for precision strikes, intelligence gathering, and air superiority in ways that were unimaginable just a few decades ago. It gives military forces the ability to operate in contested environments with a level of freedom that others simply don't have. And it's not limited to aircraft. The principles of extreme stealth are being applied to ships, drones, and even ground vehicles. Naval vessels use angled surfaces and special coatings to reduce radar visibility. Unmanned systems are designed to be small, quiet, and hard to detect. Even cyber and electronic warfare can be considered a form of stealth, hiding presence in the digital domain. Looking ahead, the future of extreme stealth is likely to involve even more advanced technologies. Adaptive materials that can change their properties in real time, active camouflage systems that can mimic the environment, and AI-driven systems that optimize stealth performance during a mission. These developments could push stealth to an entirely new level. At the same time, the battlefield itself is evolving. With more sensors, more data, and more interconnected systems, staying hidden is becoming both more difficult and more important. Extreme stealth will have to adapt, integrating with other technologies to remain effective. In the end, extreme stealth is about more than just invisibility. It's about control, controlling what the enemy can see, hear, and understand. It's about shaping the battlefield in ways that give you the advantage before a fight even begins. So the next time you think about military power, don't just think about speed, firepower, or size. Think about the ability to remain unseen, to move without detection, and to strike without warning. Because in modern warfare, the most dangerous weapon isn't always the one you can see, it's the one you never knew was there at all.